If mod of x square minus 3x plus 2 per power mod x is equal to 1, find sum of all real values of x. The options are 4, 2, 3 or 1. Now this is an interesting question of exponential equations. Here, what are the prerequisites that you need to understand? A to the power x is equal to 1. What are the conditions when it can hold? First, a is not equal to 0 and x equal to 0. Then in that case, we can say that a to the power x is equal to 1. For example, 2 raised to 0 is 1. Now, again for the second part, we can say if a is equal to 1, x can be anything. For example, 1 ka cube, that is equal to 1. And third case, when a is minus 1, then x has to be even power. Why? Because minus 1 ka square is equal to 1. So for the given question, we can check for these three cases and find out the answer. So first, the power is mod x, and if mod x is equal to 0, then x will be what? 0. So if x is 0, so according to the question, if we put the value of 0 here, so what will happen? Mod of 2 to the power 0 will be equal to 1, and hence x equal to 0 is one of the solutions. Why? Because LHS is equal to RHS. Case 2, I said ki a is equal to 1. It means mod of x square minus 3x plus 2 is equal to 1. We know that when mod of x is equal to a, then x is equal to plus minus a, students. So it means x square minus 3x plus 2 is equal to 1, or x square minus 3x plus 2 is equal to minus 1. So first we solve for the first case, x square minus 3x plus 2 is equal to 1. In this case, the x turns out to be 3 plus minus root 5 by 2. Now for this case, both the solutions will be valid, plus 1 and minus 1. Since this satisfies the given equation. Now for the second case, we can consider x square minus 3x plus 2 is equal to minus 1. So again, x square minus 3x plus 3 will be equal to 0. Now the discriminant is b square minus 4ac, where b is minus 3 and a is 1 and c is 3. So the discriminant turns out to be less than 0, and hence it has no real solution. Fourth case, we can say mod of x square minus 3x plus 2 is equal to minus 1, but it is not possible. Why? Because this modulus is always non-negative. Hence there are only three solutions that are left: 0, 3 plus minus root 5 by 2, and hence the sum of the solution will be 3. So 3 is the answer.